picture. Okay, no, so let's, it's, I think, so first time I'll project with a speed u1. So then how the path of particle, the bob, will go like this. So here it is going to leave circular path. When it is leaving circular path, it will have some velocity v. This, I think most of you are familiar with the questions of these kind. Let's take this one. So what is the condition given? After leaving circular path, it has to pass through the projectile motion, and it should come like this. What should be the speed u1? I think you know most of the basic ideas. So if I take this is theta, this will be theta, this will be theta. So this length is L. So what is the length it should cover? L cos theta. This will be L sin theta. Then applying when it leaves circular path. So what is the condition? Tension should be 0. I think we all know that one. The string what happened will be loose. So then for it to what happened to pass through point 2, we have directly, I think I asked you to memorize that formula also. Second situation, what is telling? I'll write down all the equations. You solve it. Already we have discussed in class. Mu1 square should be equal to mgl plus mgl sine theta plus mv square by 2. Condition to leave circular path, who will provide required centripetal force? Mg sine theta. Or select it. Tension will become 0, then mg sine theta equal to mv square L. So like this, we can replace that theta and we'll get expression for V. From how to U1 is unknown, no? What to do? You bring the idea of projectile. So what is the time? Minus L sine theta is equal to V cos theta T minus GT square. Then what is the horizontal range? L cos theta should be equal to V sin theta into T. Solving these two, we'll get expression for V. That V I'll substitute here. Okay, with this, I'll get the theta. This theta also get theta and V I'll substitute here. I'll get the U1. I think I discussed this particular concept in class. You have this particular thing also. You know that answer also. Next part of the problem, I'll project so that it should pass through what? The point of projection. This should be the trajectory. It can happen. We have discussed it. It can happen also this one. It can pass through this also. Okay, let's see what mathematics you can apply.
So he didn't mention that it leaves the circular trajectory in second case.
Both the cases, no? So that it is given. For it to pass through point of
Complete circular motion is also possible now, sir, to pass through the point of projection.
after leaving circular path. Given, no? Second, it is given so that it passes through point of projection after leaving circular path. Okay, it should be mentioned. Projection.
Without leaving circular path, how can it pass through point of projection?
I may give some velocity where it will complete circular path.
Okay.
Okay, we'll make it. Yeah, I'll add it. Huh? So that will be easy for us. Huh? Please do remember. So definitely they want to test with some small ideas. Huh? Nothing big that one. Only thing is we must know all the what are the types of formulas what we can do. And the second situation, I don't draw the diagram. It is possible, practically it is possible for it to leave circular path and can pass through point of projection also. Of course, we don't have any much numericals in our books, but practically possible. No, just be careful, such conditions can be asked. Okay, after leaving circular path, somewhere it will come here. So the trajectory should be like this. So then again, all the same set of projectile conditions is what we are going to apply it. So here when it's leaving circular path, it will have velocity v like this. So let it be same thing, L sine theta. This is L cos theta. This is L. So this is theta. This will be theta. Only the difference is writing that equations is what? These equations, I'll continue as it is. There won't be any problem with these equations. Try to make comparison. Now, what will be the difference will be only in this equation, we are going to change it. This also let me move. So it will be minus of L plus L sine theta. Is it okay? Okay, this time of flight will be different. So let me call T2. This time of flight, let it be T1. Theta, we don't know what can be theta. Yes, this theta may be different. Yes, let it be that one. Don't bring this value here. So if you want to write it here alpha. So that will be easy for you to do comparison. Vertical circular motion, just small ideas are there. Very important topic, especially for JEE Advance. Okay, you have to calculate that ratio U2. U2 by U1 is asking. If your time permits, you calculate. Otherwise, just leave it. In exam, you must solve. There's no other way. You do have all conditions. Can it pass through this particular point? Okay, point of projection. Okay, we are able to tell, and the point of projection and point of suspension. Can it pass through this particular point? See, in exam, if it gives, okay, well, good, you can directly take it. But instead of testing what happened, instead of for any speed, can it pass through this particular point? It has to describe path like this. It has to describe a path like this. So for that, what is the requirement? This range, and it cannot ascend height more than this because it has to leave circular path means it cannot reach this particular point. So the trajectory has to be like this. For that, what you have to check it now? You go back to some formula, no? Like what speed I should project so that it should pass through one specific point. Find the minimum speed with which a particle should be projected so that it can pass through a given point. So this is the point of projection. You know this y coordinate L sine alpha. The x coordinate will be L cos alpha plus L. Check it now. So what is will it satisfy that particular speed? First you calculate the speed required for it to pass through here. Okay, no, that particular speed for it to happen. So if you provide, can the bob can have that much of speed here? Like this, you have to verify it. We don't have anywhere in the books discussion.